Most matter is going to be made up of compounds of elements. However, some matter has only one kind of atom, and when it has only one kind of atom, those individual types of atoms are called elements. And each element is going to be different from every other element, and it can only be broken down to the size of about an atom. Anything smaller than that, and it will no longer be the element that we're talking about. Now, there's 92 naturally occurring elements out in nature, and only about 25 of them are essential for life. A lot of the other ones are going to be used for other things, but 25 are necessary for life to happen. Four of them, in fact, oxygen, carbon, hydrogen, and nitrogen, make up 96% of your body weight. So that's the bulk of what we're made of is carbon, oxygen, hydrogen, and nitrogen. Okay, pictured here is the periodic table of the elements. You're not going to have to memorize it for this class, but I do want you to be familiar with a little bit of it. First of all, it's called the periodic table because there are periods or rows, and those are our elements. That's how it's organized. But it also has some groups, and the groups are what go up and down. And that kind of tells us how the elements react. All of the elements in a group tend to behave the same way. There are a couple atoms of interest, or a couple elements of interest for us. They are carbon over here, nitrogen right next to it, oxygen over here, and then our hydrogen up here. Remember, we said that these four make 96% of our body weight, so those are the important ones we need for life. We'll learn about some of the other ones as well, but that's the basics of what I wanted you to know from the periodic table. Okay, when I combine two or more elements together, we form what we call a compound, and compounds are what we tend to find out in nature more than the individual elements on their own. Now, the property of a compound can be different from the elements that make them. In our example here, we're going to talk about water real quickly. Water is made of two elements. The first is hydrogen, and hydrogen is really flammable. It burns really, really well. It's explosive when it burns. The other element in water is oxygen here, and oxygen is required for things to burn. If you take the oxygen out of a fire, the fire stops burning. It needs to have that oxygen for fire to go. So if I take something really explosive and I add to it the ability to burn, I would have this huge explosion. And that's what happens when I mix hydrogen and oxygen together and give them a little spark. But then it forms water. And water is an amazing thing. As you know, water is not very flammable. In fact, that's what we use to fight fire. So you can see how the properties of water are different than the properties of the elements that make that. Okay, here's our real simple model of the atom. I wanted to show it to you so we can show the parts of the atom. The first part is the nucleus, and that's the center here of the atom. It's filled with two subatomic particles. We find the proton, which has a positive charge, and then the neutrons, which have no charge. And together, those two form the nucleus. Now, orbiting around the nucleus in electron clouds are where we find our electrons. Those are these guys here, and they follow around in these areas. And it's not a perfect circle. This is just a simple model, but the electrons have a negative charge. So the protons are positive and the electrons are negative. Also, the protons and neutrons are about the same size, while the electrons are teeny tiny in comparison to them. And that'll be important in the next slide. So if we go back to the periodic table and we take hydrogen, one of the elements we were talking about, and then we also remember our model that we had, what we do is there's a couple things we want you to know. First, here's the element name, and in this case it's hydrogen, and then we have the element symbol. And the symbol is going to be one or two and possibly three letters. Normally they're just one or two. The first letter is always going to be capitalized, and every letter thereafter is going to be lowercase. So that's our symbol. Now, the most important thing here is this atomic number. That's how the periodic table is organized. It also tells us what element we have. And the atomic number is equal to the number of protons that we have, and that's the defining characteristic of an element. If the element is neutral, the atomic number is also equal to the number of electrons, but always, always, always it's going to be the number of protons. And then down here we have the atomic mass. And the atomic mass is equal to the number of protons plus the number of neutrons. And that's important because protons and neutrons have an atomic mass that's about equal, and then our electrons, like we said, are much smaller. They're going to be about 1/1800th the size of a proton. So they really are negligible, and we really don't count them. Okay, lastly, we're going to talk about ions and isotopes. Before we do that, I want to remind you about our friend, the proton. The proton has a positive charge. It's found in the nucleus, and it's the defining characteristic of an element. If we change the number of protons, we change which element we have. So that's not something we want to play around with. Now, we have ions. Ions involve changing the number of electrons. Okay, and remember electrons have a negative charge. So if I add electrons, I make a negative ion. If I take away electrons, I make a positive ion. And an ion, quite simply, is just an atom with a charge. And then lastly, we have our isotopes over here. And the isotopes are going to deal with the number of neutrons. Okay, and neutrons have no charge, so they don't affect that one. They're just going to determine whether it's a heavier version or a lighter version of the element. Now, our atomic mass, if you remember, was something like a decimal, and that decimal is because we take the average of all the isotopes. And some isotopes are useful. In the fact of carbon, most carbon is going to be carbon 12, which means it's going to have 6 protons and it's going to have 6 neutrons. And that's how we get this 12. But every once in a while we find carbon 14, and carbon 14 also has 6 protons because that's what says it's carbon, but this time it has 8 neutrons, and that's where we get the 14. And carbon 14 is radioactive, and we use that one for dating, but we'll get to meet him a little bit later on in the class. All right, thank you, and we'll see you in the next video.